Hi folks, it's Peter Taoussanis here with a lightning intro to Telemere. Telemere is a closure and ClojureScript library nearing stable v1 as I record this. It is a modern rewrite of Timber that is intended to be a drop-in solution for many of the most common observability needs. I'm going to show you some examples. I'm going to go quickly, feel free to pause. Here is a simple logging call. Here is a logging call at the warn level, or with the level specified in an options map. Here we provide an error, which will show up in the output. There are a lot of options available in the options map. Here's some structured logging, that is without a human readable message. Here we're using a warn level again, and using the options map again. Here is an error. And here is some arbitrary data, that is any closure or ClojureScript value, including nested data structures. Your types are retained as is throughout Telemere's pipeline. There are a lot of options available here too. Let's see some tracing. Now imagine we have some code that runs as part of a logical flow, something like a transaction, and we want to understand which flow steps occur, when, how long they take, and the parent-child relationship between steps. So basically the kind of stuff that you would get visually from tools like Jaeger or Zipkin. Telemere can give us that information in signals. Here we're adding an ID, and here we're adding a level. Tracing works with dynamic nesting. So if you're tracing and you call a function, which calls a function which has tracing, the child will register as a child of the caller. Tracing has a lot of options available too. You will notice a lot of similarities between the log, event, and trace macros that I've shown you. And the similarities are actually fundamental. Telemere does not make a hard distinction between traditional logs, structured logs, events, or traces. They are all just different kinds of signals. And a signal is just a closure or ClojureScript map, that is data, with certain keys that tell you something useful about your program's state or behavior. All signal kinds share the exact same set of possible options and content. These are documented in detail at daoenzo.com/telemere/signal-options or signal content. So what's the point? What's the value of this particular API? Observability matters. Software that is observable is easier to understand, it's easier to debug, and ultimately tends to be more robust. But building observable systems in practice can be surprisingly difficult, and a lot of traditional tools make the job way more complicated, way more difficult than it needs to be, even when you're just trying to get started. So Telemere is an attempt to use Clojure's unique strengths, and in particular its macro system, to offer a unique and practical API to help make observability much easier. You use it instead of a traditional logging library like Timber. It covers logging, but it will also grow with you as your needs grow beyond simple logging. It offers a really simple API for getting started and for simple stuff, right? You've basically seen the whole API. But the same API holds a huge amount of flexibility and power for if or when you need it. So again, the idea is to take advantage of Clojure to provide a unified and opinionated API that offers the ergonomics and beginner friendliness of something super minimal, but without sacrificing on performance or capabilities. I'm now going to try to show you a little of what Telemere can do. I'm going to go fast. Feel free to pause. Here we're using random sampling. So our event call will create a signal only 30% of the time. Other calls will no up. Here we are using rate limiting. So our event call will create a signal at most once every second and at most 5 times every minute. Other calls will no up. Here we restrict the rate limiting by some program state. So for example, each user might get their own limit. And here we create a signal that includes both structured and unstructured content, which is actually a great way to transition in practice from unstructured legacy logs to structured logs. You basically just start adding structured data to your pre-existing log call sites over time. Here we catch errors in a future to error signals with the given ID. And here we set up arbitrary bindings, let bindings, that can be used in our structured data and signal messages. So this code only evaluates when all filtering passes, including sampling, rate limiting, ID filters, namespace filters, etc. The costs are completely lazy and conditional. By the way, this feature is really useful if you want to format complex messages, which might be expensive to calculate, or if you have complex data that you want to calculate. For example, you want to do some sort of analysis of your current system state that you want to include in a signal, but you don't want to pay for that unless you actually have the relevant filters enabled. Here we set a minimum signal level. Signals with a lower level will no op. And here we restrict the minimum level to a particular signal kind, so the log kind. Here we restrict the minimum level to log signals in the current namespace only. Namespace patterns can also be used. Here we filter signals by ID pattern. Other signals will no op. All filters are highly expressive and apply in constant time regardless of their complexity. Middleware lets you arbitrarily transform or filter signals based on the signal content, on your program state, or on anything else that you like. Signal handlers have independently configurable filtering, async options, backpressure modes, priorities, and a lot more. Every handler automatically generates stats by default, making it really easy to understand handler performance, backpressure, filtering behavior, etc. Telemere has really great out-the-box interop with OpenTelemetry and OpenTelemetry tools and exporters, including Jaeger and Zipkin. And Telemere can easily act as a provider for SLF4J, meaning you can use it as a backend for your Java logging. Telemere also has great support for ClojureTools.logging. Telemere has the most extensive documentation that I've written for library. There is plenty of info both online and directly in your REPL, and the docs and examples include extensive content for folks who are new to Clojure and who are new to observability in general. So there's a lot more to say, but I want to keep this short, so I'm going to end here. Thank you for watching, and thank you to Clojurists Together, to Newbank, and to everyone else that has kindly helped support my open source work. Feel free to ping me on GitHub or on Slack if you have any questions or suggestions. That's it. Cheers.